The first logic family we will be dealing with is TTL, and TTL is also called as transistor logic. Okay, so the full form of TTL is transistor logic. So in this, basically it will be the circuit will be with transistors. Okay, so there are many configurations for TTL. So we'll first deal with the simplest, the very basic configuration of TTL, and that is the open collector. TTL in the open collector configuration. So this is a multi-emitter transistor. Q1. Then you have another transistor Q3. These are resistors. Q2. You have another transistor Q3. So this is your open collector transistor configuration. Okay. So in this, we can see that you have a multi-emitter transistor Q1. Q1 is a multi-emitter transistor. That is, you have two emitters. Usually a transistor will have a single emitter, single base and a single collector. Here you have multi-emitter, and depending on how many inputs are there for your gate, so many emitters will be there in this particular transistor. So this is a 2-input gate, so you have 2 emitters. Then you have Q2 and Q3. So we are going to find out what the output is when you apply different inputs. Okay, so output is taken from the collector of Q3. So first what we'll do is, we'll just analyze this Q1. So Q1, the input is given to the emitter. So we know that Q1 is a multi-emitter transistor, and this is the base emitter voltage. You can see that this is an NPN transistor. NPN transistor means emitter base collector, NPN. So this is N. this is N, this is P, and this is N. So this is N, this is P, this is N, this is N, this is P, this is N, N, P, N. This is also N. Okay. So we know that for an NPN transistor, the transistor is on when the base emitter voltage is at least 0.5 volt. That is, base emitter voltage should be equal to or greater than cut-in voltage. That is approximately 0.5 volt, 0.5 to 0.7 volt it will be. So the base emitter voltage should be around this voltage. Then this particular transistor will be on. And for this transistor to be on, the base emitter voltage, that is, it is plus 0.5 to plus 0.7 volt, that range. So you can see that I've put a positive sign here and a negative sign here. So that means that the base should be more positive than the emitter by a voltage VBE, which is in this particular range. That is, the emitter should be negative with respect to or lesser than with respect to the base. So what should the value at A and B be so that this particular transistor is on? Here we are dealing with digital circuits. So I'll talk in terms of zeros and ones. 0 means low and 1 means a high voltage. So should you give a high or a low to A and B so that this transistor is on? So for a multi-emitter transistor, at least one of the emitter, okay, it is base emitter junction means you have two emitters. So we should consider at least one base emitter junction. Since you have two emitters and one base, you have two base emitters, right? So at least one should be true. So the emitter should be lesser than the base. Base is connected to 5 volt. 5 volt will naturally be a high. So A or B, one of these should be a 0 because it's N. So a lower voltage should be connected to N than the base for this transistor to be on. So we'll think that A, B, and here you have the output. You'll just write all the combinations. So at least one is low, we'll check. So it can be either this or this or this. Okay, so one of these A or B. Okay, it's either 0, 0 or 0, 1 or 1, 0. One of these is low. If one of these is low, then the base emitter voltage will be positive. Base emitter voltage is positive and it's greater than cut-in voltage because here you have 5 volts. So naturally, after the voltage drop across this resistor, you will have more than 0.5 volt across the base emitter, so that this transistor is on. So in all these cases, Q1 is on. because in all these cases one of the base is at a lesser voltage than the base. One of the emitters is at a lesser voltage than the base. So the base emitter voltage is positive, this transistor is on. And for an NPN transistor, if this transistor is on, then the voltage at the collector will be low. Normally an NPN transistor and if one of these emitters is at a low voltage, this is VBE, this will be at a lower voltage. Why? Base emitter voltage is positive, transistor is on. Transistor is on means what? This will act as a closed switch. Closed switch means the switch is closed. This is 5 volt. And you're taking the output from here. This is the collector. So this is closed. So you're shorting this to 0. So the collector will be at a low potential. 0 means logic 0. Okay. So the collector will be at a low potential. Suppose this is off, transistor is off, then it will act as a open switch. Then the voltage at the collector is 5 volt. So you can say that if the transistor is on, when is the transistor on? When A or B, either one or both A and B are 0. So in these 3 cases, the transistor Q1 is on. If the transistor Q1 is on, it will act as a closed switch. If it's a closed switch, then the voltage at the collector is a low. If both A and B are 1, then base emitter voltage will be less than the cut-in voltage, so that Q1 is off and the voltage at the collector will be high because it's acting as a open switch. Okay, so now we are considering the first 3 cases. The voltage here is low. Voltage here is low. So here if you see, you have Q2 and Q3. Yes, the low voltage is coming at the base of Q2 with respect to ground. So in order to make Q2 on, the base should be more positive than the emitter. But base itself is at a low voltage. So this is off. So this is off means the voltage at P will be a low voltage. So Q3 is also off. So you can say that in the case of TTL, this Q2 and Q3, see, this is P, this is N, this is P, this is N. So you can say that it is like 2 diodes in series. It is P, N, P, N. So this is the voltage, say VQ2. Voltage at this point with respect to ground. So VQ2 should be sufficiently high so that both Q2 and Q3, base emitter of Q2 and Q3 are on. Then only Q2 and Q3 is on. So Q2 and Q3 will either be on at a time, both be on at a time, or will be both off at a time. Simultaneously, you can't have one of the transistors on and the other off because they are in series. So either Q2 and Q3 are on or Q2 and Q3 are off. You can't have Q2 on and Q3 off or the other way around because they are connected like this. So what should the voltage at VQ2 be so that both VQ2 and Q2 and Q3 are on? It should be equal to 2 diode voltages. So if one diode voltage is like we told here 0.5 to 0.7, so suppose it's 0.5, then VQ2 should be greater than 1 volt. 0.5 plus 0.5, 1 volt. Then only Q2 and Q3 will be on. So in this particular case, first three cases, here you have a low. It is not equal to 1 volt. It's approximately 0.2 volt. So low means 0.2 volt. So Q2 is off and Q3 is off. Q3 is off means what? Here you have the output. This is Q3. This is an open switch. Why open switch? Because it's off. A transistor will act as a closed switch if it is on and open switch if it is off. So it is like this. So output is taken from where? See, here you don't have a connection to ground and you don't have a connection to, this is VCC, the battery. So if Q3 is off, the output is floating. There is no connection to a voltage. So that is called as high impedance state. Or high impedance means what? Resistance. High impedance state. That is an open circuit. High impedance state is just an open circuit. So in an open collector TTL, if one of the inputs is 0, then the output is in high impedance state. That is denoted by Z. Now if suppose A and B both are 1. Both are 1 means N or the emitter is at a high voltage. So the difference between the emitter and base is very low, so that it's not equal to the cut-in voltage, and Q2 is off. Sorry, Q1 is off. In the last case, Q1 is off. Q1 is off means what? The voltage here will be high because this is acting as an open switch and the 5 volt will come here. So this will be high. High means sufficiently high, greater than 1 volt. So that we need just 1 volt for the both the transistors to be on. Here you have more than 1 volt. So Q2 and Q3 both are on. So Q3 is on. Q3 is on means what? This will act as a closed switch. Closed switch means output will be low. It is connected to ground, so it will be low. So here the output will be 0. So that is a open collector TTL. Next, we'll modify this particular circuit and we'll just connect a resistor to the collector. You are not keeping the collector of Q3 open as in the first case. We are connecting it to the VCC through a resistor. So rest everything is the same. In the first three cases, Q1 is on, Q2 and Q3 are off. Okay, so when AB is 0, 0, 0, 1, 1, 0, Q1 on, Q2, Q3, Q2 and Q3 off. So if you see the output section, how is this? This is VCC, resistor, output. The transistor is off. Transistor is off means what? There is no conducting path, because the current does not conduct through a open circuit. Here it is open, so there is no complete path for the current to flow. So there is no current. So since there is no current, what is the output? Here what is the output? The output here is VCC minus the current I into R. But I is 0. So output equal to VCC. So here output is VCC in these three cases. VCC is 5 volt. 5 volt means it is a high voltage. And in the last case, when both are equal to 1, here you have a Q1 is off. Q1 off means here you have high. High means Q2 and Q3 are on. Q2 and Q3 on means this will act as an closed circuit. So this is VCC minus I into R. You have a current flowing because this is a closed circuit. And what is the current? Current is VCC by R, because here the resistance is very less. So maximum current will flow through the circuit, and the maximum current flowing through the resistor will make the drop across the resistor maximum. So VCC minus IR means what? I is equal to VCC by R. So VCC minus VCC by R into R. So that is equal to, approximately equal to 0. So this is 0. So what does this look like? Which gate does this look like? If one of the inputs is 0, Q1 is on. Then the output is 1. If both the inputs are 1, then the output is 0 because Q1 is off. This is a NAND gate. So this is the case with the TTL NAND gate. So TTL NAND gate is the basic circuit for a TTL. TTL NAND is the basic circuit for a TTL logic family.